So now it's about becoming a smart trig class. We've been looking at some of these functions and we're realizing that certain functions are positive or negative depending which quadrant that they fall in. In the first quadrant, all the functions are positive. In the second function or the second quadrant, the sine and its reciprocal are positive. In the third quadrant, tangent and its cotangent are positive. And then in the fourth quadrant, we will always have the cosine and the secant being positive. So based on this, you guys are a smart trig class. Why do I say that? Well, that might be a way to help you remember of which areas are the things positive in. So a smart trig class A represents all. In the first quadrant, all are positive. Smart begins with S, which tells me in the second quadrant, sine is positive and its reciprocal function. T stands for tangent. Tangent and its reciprocal is positive in the third quadrant. And the fourth word represents cosine, C for cosine, and cosine and its reciprocal are positive. So how can we help remember which functions are positive depending on which quadrant they're in? Just remember that you guys are a smart trig class. So as an example of being a smart trig class, let's try it out. If we know that a tangent of theta is less than 0, negative, but the cosine of theta is positive, greater than 0, so which quadrant would this angle lie in? Well, if we look at the tangent having to be negative, that rules out quadrants 3 and 1, because 3 and 1, all tangents are positive. Then we want to look at the cosine of theta. Where is that positive at? Well, cosine is only positive with positive x values. So that's in quadrant 4 or quadrant 1. So where is the overlap between those two? Well, that would be quadrant 4. Quadrant 4, the tangent is not positive, therefore it has to be negative, and the cosine is positive in quadrant 4. Here's a fun problem that we can use some of these ideas about to help discover a result. So let's say that we're given a tangent of theta is negative 2/3, and we know the cosine of theta is positive. So based off that, can we identify what the cosine of theta and the cosecant of theta are? I think that we can. So let's start to unwind and unravel some of the things that we know. Tangent of theta is negative 2/3. Tangent was a y over an x. So I have a 2 over a 3. However, we don't know if the negative is associated with the x or with the y, because negative 2/3 could be negative 2 over 3 or 2 over negative 3. So how can we determine which value is the negative associated with? That's where the cosine of theta being positive comes in. If the cosine of theta is positive, that tells me my x values are positive. So if my x is positive, then my y has to be the negative 2. Okay, based on that, then we can draw a little bit of a map here. We know we have a point at negative 2 and 3. That's what the tangent is. It's a ratio. So I can drop down 2 over 3. So I have some point right there. That's at the point over 3 and down negative 2. That's helpful because then I can determine, one, it's helpful because it starts to let me have an idea what the angle looks like. I know that it was in quadrant, it lied in that fourth quadrant because of the descriptions we have. We want to look at what its radius is at this particular point. So in order to find cosine and cosecant, we need to have radiuses. Radius again was the square root of x squared plus y squared, which in this case was a negative 3 or a 3 squared plus a negative 2 squared. That's a 9 plus a 4, that equals a root 13. So now I think we have all the information we needed. What we had to find first was, one, is my x or my y value negative? And we were able to determine that based on the signs and where we expect the locations to be. Then we also had to determine what its radius was as well. From there, we can figure out what the cosine of theta is. Remember cosine of theta? That was my x value over my radius. So that becomes x value, which is a 3, over my radius, which is root 13. And then we would need to rationalize that. So multiply both by root 13s. And that equals a cosine of theta, which is 3 root 13 over 13. Now the cosecant, to find the cosecant, do we remember that? What that was? Cosecant of theta, that was my radius over my x or my y. That was over my cosecant is the reciprocal of sine. Sine dealt with y's, so that was my r over my y. My radius is defined as root 13. My y is a negative 2. And then we can rewrite that as negative root 13 over a 2. So based on understanding a little bit of the location of our angle, we were able to help identify what the trigonometric functions were of a couple of other trig functions.